June 2024. Scientists loaded fragments of 4,000-year-old Sumerian tablets into a custom AI system, expecting dull ledgers or myth. Instead, they found warnings, burning stones, red skies, rivers flowing backward, and chilling patterns that mirror real disaster records. These translations should not exist, yet here they are. If the machines are right, our own history may be caught in a destructive cycle the ancients desperately tried to warn us about. What else did the Sumerians hide, and why are we only seeing it now? Under the harsh glare of lab lights, battered shards of clay lie in careful rows, each fragment etched with the unmistakable wedge-shaped script of a vanished world. At Ludwig Maximilian University in Munich, a team of engineers and archaeologists gathers around these silent witnesses, determined to reverse the destruction of centuries. The old method, painstaking trial and error, matching fragments by hand, has given way to a new kind of craftsmanship. Every piece is scanned in extreme detail, photogrammetry capturing not just the visible marks, but the subtle curves, the tiniest chips, the faintest traces of ancient handling. These scans, rendered in 3 dimensions, become the raw material for an algorithm built specifically for this task. The software processes more than 1,900 fragments, each one mapped, measured, and compared. It does not just look for matching edges, it analyzes surface curvature, the depth and angle of cuneiform impressions, even the patterns of wear. Feeding this data into a convolutional neural network trained on thousands of successful joins, the system begins to predict how the pieces once fit together. The process that once stretched over months or years now unfolds in hours. The algorithm constructs a digital graph, assigning probability scores to every possible connection, weighing the evidence for each potential join. Patterns emerge on the screen, lines of cuneiform text slowly reuniting, seams aligning, the ghostly outlines of tablets taking shape. Engineers and archaeologists watch as the AI assembles what was once a hopeless jumble. Some tablets, previously nothing but debris, reappear as nearly whole records, their missing corners reconstructed with digital best guesses. The system flags areas of uncertainty, inviting specialists to review the matches before any physical restoration begins. This careful balance between machine prediction and human expertise ensures that the reconstructions are both rapid and reliable. In the LMU lab, the mood is tense but hopeful. Each reconstructed tablet is more than an artifact. It is a recovered voice from the world's first cities. The speed is staggering. What used to demand months of labor now takes only hours, allowing the team to process over 1,900 fragments with a precision that was once unimaginable. As the assembled tablets move toward the next phase, translation, the sense of anticipation grows. Every successful match brings the ancient world into sharper focus, turning piles of broken clay into readable surfaces and offering a glimpse into the daily lives, laws, and stories of Sumerian civilization. In a quiet lab at Tel Aviv University, computer scientists and linguists gather around glowing monitors, their screens filled with rows of ancient wedge-shaped symbols. The challenge is daunting: how to bridge a gap of 4,000 years between the minds of Sumerian scribes and modern readers. For decades, experts relied on painstaking transliteration, turning cuneiform signs into Latin letters, then working line by line to decode the meaning. Now a sequence-to-sequence neural translation pipeline takes over, built on the latest advances in machine learning. The model does not simply look up words. It reads entire sentences, weighing the context of each sign. Attention maps highlight which symbols the AI considers most important, tracing the logic behind every decision. Confidence scores appear beside each phrase, signaling how sure the machine is in its choice of words. When the signs follow familiar patterns, royal decrees, omen lists, legal contracts, the translations approach fluency. The BLU score, a standard measure for machine translation, hovers around 37 for Akkadian to English. That is close to what early versions of Google Translate achieved for living languages, and a major leap for a script no one has spoken for millennia. Israeli researchers, led by teams at Tel Aviv and Ariel University, have pushed this technology further. Their system can take a photograph of a clay tablet, recognize the cuneiform, and produce an English translation in a matter of seconds. For the first time, non-specialists can glimpse the content of texts that once required years of training to interpret. The AI speed is breathtaking, but its limits are clear. Formulaic texts come through with surprising clarity, but literary works, poetry, letters, prayers, often trip up the model. Here the system can hallucinate, inventing phrases unrelated to the original. Oversight protocols flag these cases, alerting human experts to review and correct the output before any translation is published. The neural pipeline is not a replacement for scholarship, but a powerful tool that multiplies the reach of every expert. Each translated line is a collaboration between ancient writer, modern machine, and human reviewer. The result is a growing trove of English phrases, ready for deeper analysis. The next step is examining what these newly accessible texts actually say and what they might reveal about the world's first civilization. At the heart of the Sumerian story lies a physical reality: slabs of clay, pressed with ancient intentions, recovered from beneath the soil of southern Iraq. Girsu, once a thriving city on the banks of the Tigris, yielded more than 200 tablets during recent excavations led by the British Museum and the Iraqi State Board of Antiquities. Each tablet carries a distinct signature, not just in the wedge marks of cuneiform, but in the sheen of bitumen that still clings to its surface. This black, tar-like layer, drawn from the earth itself, served as a seal against time. Where centuries of flood, fire, and shifting sands have worn away the records of other cities, the bitumen coating preserved the fine details of these texts, locking out moisture and slowing the steady creep of erosion. Conservation scientists at the Iraq Museum and the British Museum trace each tablet's journey from excavation trench to laboratory bench. Every find is logged with an accession number, tagged with the coordinates of its discovery, and photographed in situ. The chain of custody remains unbroken, a point of pride for the teams who know the risks of forgery and illicit trade. Once unearthed, the tablets are handled with gloves, their surfaces examined for any sign of modern tampering. Gas chromatography and X-ray fluorescence confirm the composition of the bitumen, matching it to natural seeps in the region and ruling out recent application. The chemical fingerprint is unmistakably authenticity. In controlled environments, conservators gently remove surface dust, but the bitumen itself is left undisturbed. It is this layer that has protected the cuneiform impressions, each wedge, each line, rendering them crisp even after 4,000 years. The tablets vary in size and content. Some are small enough to fit in a palm, listing rations or work assignments. Others are broad and heavy, inscribed with longer records or temple inventories. Many are nearly complete, with only minor chips at the edges, a rarity in the world of Mesopotamian archaeology, where most finds are fragmented and worn. The integrity of these tablets is more than a matter of preservation. It is the foundation for everything that follows. When AI systems and human translators turn their attention to these texts, they do so with the confidence that the records are authentic and the script is legible. The bitumen, a simple product of ancient chemistry, has become the silent partner in a modern investigation. Without it, the subtle marks that distinguish a royal order from an omen or a warning from a routine account might have vanished into dust. Instead, the tablets of Girsu stand as some of the best preserved voices from Sumer, their words waiting to be translated, their meaning still intact after thousands of years. On a monitor in the Tel Aviv lab, a single line of cuneiform hovers in digital clarity. AI's translation appears beneath it, flanked by a green bar, confidence 74%. The phrase is blunt: stones fell from the sky, burning the fields. Next to it, a logogram once read as rain is reclassified by the neural model. Now it renders as firestone, a term that had eluded decades of human translators. AI marks the decision with a yellow highlight, signaling a lexical pivot. Its probability for this reading sits just above 72%. Another tablet, nearly whole, yields a line that chills the room. The river turned back upon itself, the waters ran bitter. The translation system presents two options, but assigns the higher score to turned back, not dried up. The wedge marks for reverse and bitter are cross-referenced with hundreds of similar phrases in the training corpus. In the margin, the system's attention map glows over the determinative for river, weighting it as the key to the sentence's meaning. A third phrase emerges, flagged with the model's highest confidence yet, over 80%. The sky burned red for many days. The sun was veiled. In the code's output, burned red replaces the older reading of clouded or stormy. AI's pattern matching process, fueled by thousands of parallel records, suggests this is no poetic flourish. The model's certainty is underscored by the absence of alternative readings in its top 5 predictions. The lab's linguists pause over a fourth line. The stars hunted across the heavens, bringing fear to the land. Here, the neural net hesitates, confidence dipping to 68%, but still above the threshold for provisional acceptance. The phrase "stars hunted" had previously been dismissed as metaphor, but the model's statistical analysis links it to omens of celestial disturbance, a pattern that recurs in omen lists and kingly chronicles. Each phrase arrives with its own measure of doubt, but the pattern is hard to ignore. AI's flagged logograms, confidence scores, and reinterpreted determinatives draw attention to warnings that once seemed buried in myth. Burning stones, reversing rivers, red skies, words of disaster recorded with the plainness of a ledger entry. The translation pipeline leaves a digital trail, every lexical pivot, every probability score, every highlighted uncertainty. The result is not a single revelation, but a chorus of alarms, each one demanding scrutiny, each one pushing for scientific validation. The ancient tablets do not whisper, they warn, in a language that grows sharper with every new line decoded. In the lowlands between the Tigris and Euphrates, the evidence of an ancient disaster lies not in legend, but in the ground itself. Field geologists working across southern Iraq have cored deep into the earth, extracting cylinders of sediment that read like a silent diary of the land. At depths corresponding to around 4,200 years ago, the cores reveal a sudden, thick band of dust, an unmistakable spike in wind-blown deposition. This layer stands out from centuries of river silt, its fine grains blown in from distant deserts, settling over abandoned fields and empty canals. Along the old courses of the Euphrates, the story continues. Satellite images and on-the-ground surveys trace the ghostly outlines of irrigation canals, once vital lifelines for Sumerian cities. These channels, some stretching for miles, are now choked with wind-blown sand and silt. Radiocarbon dating of organic remains from canal beds and settlement layers confirms a sharp break in occupation just after 2200 BCE. Archaeologists find thick deposits of dust overlaying the last traces of habitation, mud brick walls slumped and buried, pottery scattered and sealed by a blanket of windborne earth. The pattern repeats across the region. In the heart of what was Akkad, riverbeds that once ran year-round show layers of gravel capped by sterile dust. Pollen analysis from core samples points to a sudden collapse of wetland vegetation, replaced by drought-tolerant shrubs and desert grasses. The shift is abrupt, not gradual. Charred plant remains and isotopic signatures in the soil match a period of intense aridity, with rainfall dropping to a fraction of previous centuries. The land dried, the rivers shrank, and the canals, so carefully engineered by Sumerian hands, were left to fill with dust. These findings align with the stark words found on the tablets: rivers running bitter, skies veiled, fields scorched. But here the story is written in layers of earth rather than lines of script. The archaeological record confirms a period of environmental stress that matches the calamities described in Sumerian accounts. The dust layers and abandoned waterways are not just relics, they are the physical imprint of a drought so severe it forced entire cities to empty, leaving behind only the silent testimony of soil and stone. High in the Greenland ice, a faint but unmistakable signal waits for those who know where to look. Scientists extract slender cylinders of ancient ice, each layer a frozen record of the atmosphere stretching back thousands of years. Within these cores, a band of dust and sulfate stands out, its chemistry distinct, its timing precise. The anomaly centers around 4,200 years ago, give or take half a century. When climate statisticians run Bayesian models to align these ice core records with archaeological and textual evidence from Mesopotamia, the overlap is striking. there is a 75% probability that the spike in atmospheric dust matches the window of disaster described in Sumerian and Akkadian records. The GIS-P2 and NDRIP datasets, drawn from deep within the Greenland ice sheet, reveal a sudden surge in dust and a subtle rise in sulfate. These signals are not random. They coincide with the collapse of irrigation systems and the abandonment of cities across southern Iraq. The same period appears in sediment cores from the Tigris and Euphrates. A dust layer, thick and unmistakable, caps the last traces of Sumerian fields. Bayesian analysis adds a new layer of confidence. By integrating radiocarbon dates from archaeological sites, the known chronology of Akkadian kings, and the precise stratigraphy of the ice, researchers can tighten the window of the catastrophe to within 50 years. The probability that these events are unrelated drops with every new data point. The signals in the ice and the stories pressed into clay begin to align, not as isolated incidents, but as parts of a single, global episode. Yet questions remain. The ice core record shows a sharp, short-lived spike, more abrupt than a slow, natural shift in climate. Some researchers wonder whether the sulfate and dust could signal a volcanic eruption, a meteor impact, or a combination of both. Others point to the absence of certain markers, like volcanic glass or impact spherules, in the sediments. The statistical models can only go so far. The mechanism behind the anomaly is still up for debate. What is clear is the temporal precision now possible, an overlap between physical evidence and ancient record that was once impossible to prove. The next challenge is to probe the cause behind the signals and to ask whether the tablets' descriptions of burning skies and failed rivers were the memories of witnesses or the myths of survivors. Sumerian scribes were more than keepers of myth and law. They were careful observers, measuring the world with a precision that still surprises. Their base 60 system, invented over 5,000 years ago, shaped how they counted goods, tracked time, and charted the heavens. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. These familiar numbers trace back to the clay tablets of Sumer. But the reach of their mathematics extended even further. On the Mulopin star catalog, a series of tablets compiled centuries before the Greeks, Sumerian astronomers recorded the positions and risings of stars, planets, and the moon with remarkable accuracy. They tracked the paths of Jupiter, Venus, Mars, Mercury, and Saturn, noting how each wandered against the fixed stars. Some tablets detailed the division of the sky into precise angles, using a system that would later underpin Babylonian and Greek astronomy. The scribes did not just watch the sky, they measured it, predicting eclipses, mapping solstices, and noting the slow drift of the equinoxes over generations. Their attention to detail was not limited to the cosmos. Medical texts, some only recently translated, reveal an empirical approach to health that stands apart from later magical thinking. Clay tablets describe the examination of wounds, the cleaning of injuries with beer or oil, and the use of bandages made from wool or linen. More striking are the diagnostic omens, lines that record the rate and rhythm of a patient's pulse, the color of skin, the clarity of urine, and the sound of a cough. In these records, terms for pulse such as libu tapu or heart throbbing appear alongside observations about fever and swelling. The scribes drew connections between symptoms and outcomes, building a kind of early clinical record. From the movement of the planets to the beating of the human heart, the Sumerians measured and recorded what they saw. Their legacy is not just the myths they left behind, but the numbers, angles, and observations that allowed them to predict, diagnose, and sometimes warn. The credibility of their warnings rests on this foundation of careful measurement, a scientific impulse that echoes through every wedge pressed into clay. Desert glass, scattered across ancient Mesopotamian plains, tells a story written in heat. Samples collected from sites near former Sumerian settlements show a structure that can only be formed at temperatures above 1,700 degrees Celsius, far hotter than any kiln or open fire known from the Bronze Age. Material scientists, intrigued by these fragments, run spectrographic analyses that confirm the glass was created in a single, violent event. Theories range from lightning strikes to meteor impacts, but the sheer scale and distribution suggest something larger, an episode of burning that left the ground vitrified. Meanwhile, in museum storerooms and private collections, another anomaly draws attention. Clay jars with copper cylinders and iron rods dated to the Parthian period between 250 BCE and 224 CE surface in archaeological reports. When filled with acidic liquid, so-called Baghdad batteries produce a measurable electric current, barely enough to tingle the skin, but unmistakable. The function of these jars remains debated. Some propose they were used for electroplating, others for ritual or medicinal purposes. Yet the fact remains that ancient craftsmen understood how to create and contain an electrical charge centuries before Galvani or Volta. The connection between the physical and the textual grows harder to ignore. Sumerian tablets, now translated with the help of AI, describe burning stones that scorched the earth and poisoned fields. For decades, scholars dismissed these as metaphors for war or famine. But the presence of desert glass, material evidence of temperatures reached only by cosmic impacts or artificial explosions, raises new questions. Could the phrase burning stone refer to a meteor strike, or even to a technological disaster lost to time? Baghdad-style jars, though younger than the Sumerian texts, hint at an ancient curiosity about energy, current, and transformation. Each artifact, whether glass or clay, becomes a silent witness to a world where fire from the sky was not just a story, but a memory pressed into the earth itself. In ancient Sumer, the concept of kingship was never just a matter of politics or military might. Power rested on a foundation of myth, ritual, and the careful crafting of lineage. Scribes, working in the service of temples and palaces, pressed the king list into clay, an official record that traced the succession of rulers back through the mists of time. The earliest names in these lists, like Alulim and Dumuzid, are assigned reigns of tens of thousands of years. To modern eyes, these numbers seem impossible, but in their original context, they served a purpose beyond simple record-keeping. Long reigns signaled a connection to the divine, a period when gods and humans mingled, and the world operated under a different set of rules. The Sumerians believed that the right to rule descended from heaven itself, a gift passed down through chosen families. Royal inscriptions often invoked the favor of gods like Enlil or Inanna, linking each king's authority to acts of cosmic order. Craftsmen and scribes shaped this narrative with every line they inscribed, reinforcing the idea that the king was not merely a man, but a vessel for divine will. When a new dynasty rose, its scribes sometimes rewrote the past, inserting ancestors into the king list or extending reigns to match legendary figures. These literary devices gave rulers legitimacy, anchoring their claims in a tradition that stretched back to the dawn of civilization. Material evidence from royal tombs adds another layer to this story. In the city of Ur, the tomb of Queen Puabi, dated to around 2600 BCE, yielded treasures of gold, lapis, and carnelian. Among the remains, archaeologists found a skull with an unusual, elongated shape, naturally formed, not the result of binding or artificial shaping. While some have speculated about the meaning of this feature, most experts see it as a variation within the population, perhaps reflecting a distinct lineage or regional ancestry. The tomb's contents, musical instruments, elaborate headdresses, and the remains of attendants speak to the careful orchestration of royal identity. Every artifact, every inscription reinforced the queen's exceptional status, blurring the line between human and divine. The tradition of recording impossibly long reigns and emphasizing physical distinctiveness was not unique to Sumer. Across the ancient world, rulers claimed descent from gods, using myth and material culture to justify their power. In Sumer, the king list and royal burials worked together to create a story of continuity and legitimacy. These were not literal histories, but carefully constructed narratives, shaped by the hands of scribes and the ambitions of kings. As AI systems translate and analyze these texts, the symbolic nature of these traditions becomes clearer, reminding us that ancient claims of divine descent were tools of authority, not simple statements of fact. In 1976, Zecharia Sitchin published the book The 12th Planet, claiming that Sumerian tablets described a lost world called Nibiru and a race of advanced beings, the Anunnaki, who shaped human history. His theory proposed that Nibiru follows a vast elliptical orbit, returning near Earth every 3,600 years. According to Sitchin, these sky gods came in search of gold to repair their atmosphere and, finding labor too harsh, engineered humans as workers. He pointed to Sumerian king lists, myths, and astronomical texts as coded evidence, arguing that the tablets held secrets missed by mainstream scholars. Academic response was swift and unambiguous. Samuel Noah Kramer, one of the most respected Sumeriologists, dismissed Sitchin's readings as imaginative but unsupported. Kramer read Sumerian myths as poetic explanations for the unknown, not literal records of cosmic visitors. Linguists and archaeologists noted that the word Nibiru appears in cuneiform texts, but not as a planet. It often means a crossing point, or a star associated with Jupiter or Mercury. No Sumerian or Akkadian text names Nibiru as a rogue planet or describes its periodic return. The Anunnaki, in verified translations, are a pantheon of gods, not extraterrestrial engineers. Peer-reviewed critiques highlighted Sitchin's lack of formal training in Sumerian or Akkadian. Specialists checked his translations against standard lexicons, finding frequent errors and creative liberties. His claims about advanced knowledge, like the idea that the Sumerians knew all planets, run up against the actual content of the tablets, which name 5 visible planets, not a hidden 12th world. The king lists, with their immense reigns, are read by scholars as symbolic, mythic timescales meant to connect kings to the divine, not as evidence of superhuman rulers. Genetics adds another layer. Recent studies show that non-African humans share 1 to 4% of their DNA with Neanderthals, evidence of ancient interbreeding. Sitchin's narrative of engineered hybrids finds no support here. The genetic record points to natural mixing among hominin groups, tens of thousands of years before Sumerian civilization. There is no genetic anomaly in the remains from royal tombs at Ur, no evidence of non-human ancestry or traits that would suggest intervention by outsiders. Sitchin's ideas continue to attract attention in popular culture, often blurring the boundary between speculation and evidence. Yet, every major claim has been scrutinized and found wanting by experts trained in the languages and science of the ancient Near East. The debate between fringe interpretations and academic consensus is sharp, and for viewers, the challenge is to weigh extraordinary stories against the standards of proof demanded by archaeology, linguistics, and genetics. Today, AI deciphers ancient voices faster than ever, yet the real warnings echo from our own cycles: environmental collapse, lost knowledge, missed lessons. Genuine Sumerian records show civilizations rise and fall with climate and hubris. As we scan clay for hidden truths, the greatest danger lies not in what's uncovered, but in what's ignored. History's patterns repeat unless we choose to break them. What would you do differently, knowing what they knew?